Hi there, my name is Emmy and I'll be your guide for your final module of Day 6. I'll be talking to you about the applications of the second derivative. Please pause this presentation at any time when you need more time to think about something. The first derivative and the second derivative can be used to calculate the velocity and acceleration of a moving body. If s is a function of time t that gives the distance of the body from a fixed point, then the first derivative of s with respect to t gives a velocity at time t. And the second derivative of s with respect to t gives the acceleration at time t. For example, if the distance in meters of a moving car from a certain point at time t is given by s equals to 2t squared plus 5, then consider finding the distance of the car after 5 seconds, the velocity of the car after 3 seconds, and the acceleration after 5 seconds. Let's start by answering the first question. Note that the function of distance can be found on the top right-hand corner of this slide. To find the distance, we simply substitute t equals to 5 into s and get 55 meters. To find the velocity after 3 seconds, first differentiate s to get the velocity and substitute t equals to 3 into this velocity function. So the velocity is 12 meters per second after 3 seconds. To find the acceleration after 5 seconds, differentiate the velocity to get the acceleration at time t and substitute t equals to 5 into this. So the acceleration is 4 meters per second after 5 seconds. Let's consider another example. If a cannon is fired directly upwards, the cannonball is at a height given by s equals to 98t minus 4.9t squared after t seconds. Find the initial velocity, the acceleration, the maximum height, and how long it takes to hit the ground. The velocity is given by 98 minus 9.8t. The acceleration is found by differentiating the velocity, so here it is given by minus 9.8. Now, the initial velocity can be found by substituting t equals to 0 into the velocity function, which will give 120 meters per second. The acceleration is a constant and is given by minus 9.8 meters per second. Notice that the acceleration is negative, and in fact this is an acceleration due to gravity. Keep in mind that both velocity and acceleration have direction. If the cannonball has a positive velocity, it is moving upwards. Negative velocity means that the cannon is moving downwards. Next, we have to find how high the cannonball goes. Think about the physical situation. The cannonball is moving upwards, so it has a positive velocity, but eventually due to acceleration due to gravity, the cannonball will slow down and momentarily come to a rest, then move downwards. Thus the cannonball reaches its peak height when the velocity is 0, that is when 98 minus 9.8t equals to 0. Solving this, we get t equals to 10. Substituting this t back into the original distance equation gives us 710. So the maximum height the cannonball reaches is 710 meters. Finally, we find how long it takes for the cannonball to hit the ground. The cannonball hits the ground when the distance to the ground is 0, so when s equals to 0. Solving for t, we get t equals to 0 or t equals to 20. Since t equals to 0 is when the cannonball is initially fired, the ball hits the ground after 20 seconds.